This short video explains the inner workings of a gadget which is enabled because of the way nature has arranged itself. It's a gadget that is used in many areas in physics, chemistry, chemical engineering, and so on. And it enables one to select either based on mass or based on energy particles of different masses and energies. So let's see how this device works. In order to understand how this device works, we first need to understand the motion of an electric charge in a magnetic field. This motion is described by a well-known equation which is written down here. It's a vector equation and it needs a bit of an explanation of how it works. So the force F on a charge which is moving with a velocity v in a magnetic field B is given by the vector cross product of V and B, and it's proportional to the charge. So the force in magnitude depends both on the amount of charge that the particle has as well as how fast the particle is moving. And furthermore, this force is neither in the direction of the particle, so it does not oppose the motion of the particle or assist it, nor is the force in the direction of the applied magnetic field. So the force definitely is caused by the magnetic field. You need to have a magnetic field, and therefore the moving particle to feel this magnetic force. However, the direction of the force is orthogonal to the applied field. We will see why this is important. I mean, it's this arrangement of the magnetic force and how it depends on the direction of the velocity and the magnetic field that gives us this unusual or unique application. This equation is sometimes known as the Lorentz equation. Now, to state it one more time, the direction is easily visualized. The direction of the force is easily visualized by using the right-hand rule as explained in this picture. So what we do is we hold our four fingers in the direction of the velocity of the particle, and we direct the four fingers towards the direction of the magnetic field. So we'll have to go back to this picture and go forward one picture. So this is the four fingers turned in the direction of the magnetic field, and if one holds the right hand in the correct manner, the direction of the thumb will then point towards the direction of the force. So that's the right hand rule. The magnitude of this force is very different compared to the electric force. The electric force is simply the product of the electric charge times the electric field and does not involve a orthogonality relationship as in the case of the magnetic force. Neither does it involve the velocity, so it's independent of how the particle is moving. So whether the particle is at rest or in motion, it feels the same electric force. Now let's see how we can exploit the difference in behavior between these two types of forces to build this velocity selector. Suppose we arrange a uniform electric field and a uniform magnetic field at right angles to each other. So this is shown here. So first we construct an electric field. We have two plates, positively charged and negatively charged each. And of course the electric field will be shown as shown by the arrows. Then we apply a magnetic field which is pointing into the plane as shown by the axis. Then we make two tiny slits, S1 and S2, and we shoot positively charged particles, let's say the charge Q with the velocity V. Now we adjust our knobs so that the D field and the electric field are adjusted to satisfy the condition that the charge times the electric field, the electric force in magnitude, equals Q times V times B, the magnetic force in magnitude. Now let's see how the two forces are arranged here. A positively charged particle will be pushed downward by the electric field. The same particle moving with a velocity v in this direction, since the magnetic field is into the board, will be pushed upward. So what this condition says is that we are balancing the downward electric force with the upward magnetic force. And when you do that, the particles entering the slit S1 will pass through the slit S2 as if nothing existed there. So even though the particles feel both the electric and the magnetic fields, by the time they enter S2, it's as if they felt nothing. So if the particles enter with different velocities, then this canceling condition will not be valid. The electric field will be different. The field needed to cancel the magnetic force will be different, and hence those particles will not enter the slit S2. So the condition we want for the velocity selector is V, the velocity of the particles, be equal to E over B. So the magnetic and the electric fields perpendicular to each other have to be arranged so that their magnitudes satisfy this equation.